So I have this line, y equals 2x minus 5. How do I go about graphing that line? What do I do? Good, start at -5. Start with my y-intercept. My y-intercept is at -5, so I start down there. And then what do I do?
Go up 2 over 1.
Good, my slope was 2 over 1, so I'm going to go up 2 over 1. Up 2 over 1. Up 2 over 1. 2 over 1, all the way up. And I've got my line. Can we name at least 4 ordered pairs that are on this line? Give me a point that is on this line. Good. 0, -5.
2, -1.
0, -5. 2, -1. Good. What else?
-3, 1.
Oops. 2, -1. 3, 1. What else? One more.
4, 3.
Yeah, 4, 3. Good. 4, 3. Okay. What about -17, -39? Is that on the line?
No.
Why not? How do you know that?
Because there's not usually 2 far apart.
Too far apart? You don't know? It definitely doesn't show up on the graph, right? My graph only goes to -6.
But it always goes, both numbers go down by -7.
Yeah, but not every time.
Yeah.
Yeah, so that doesn't really tell me whether it's on the line or not, right? It's possible that it's on the line because -17, I don't know, -39 is probably like over here down your paper. And really, like, it could be on the line, right? Could be. I'm not really sure yet. How could I figure it out for sure?
Add more to the graph.
I could add more to the graph. What else could I do?
You just add like 2.
Add by 2. What do you mean?
The graph goes down by 2.
Keeps going down by 2, so I could keep like counting down. Could do that.
You can pick the farthest.
What's that? Yeah, we can test this point in our equation. What were you going to say, Hayden, though?
I mean, you could take the farthest point on the graph and then just add by each 2. So x changes by 1 and y changes by 2. So you could just keep adding or subtracting. Subtracting.
Yeah.
5 from that one.
Yeah, and you could do that, but that probably is going to take a long time, isn't it? Yeah. So let's do this. We're gonna take that equation. Please put your phone away. Y equals 2x minus 5, and I am going to test this point. That means I'm going to plug in -17 for x and -39 for y. Why did I put the -17 in parentheses but not the -39? Because I'm multiplying by that 2. Okay, and I'm testing it. I'm asking, is this true or is this false? So -39. What's 2 times -17? -34. And what's -34 minus 5? -39. Is -39 equal to -39? Yes, that's true. So that tells me that yes, it is on the line. Even though I don't see it on my graph, I know that because that point works in the equation. We say it satisfies the equation. So every point on the line is a solution to the equation. Yeah.
Couldn't you just tell this is true because both are negative, and that in the line is heading into the double negative quarter of the.
Yeah, but what if I said negative 1640, negative 40? That doesn't work, but they're both negative. So yes, you're right in thinking like, oh, well, that would make sense if it's on the line, but I don't know for sure until I plug it in. Does that answer your question?
Oh, on the line. Okay.
On the line.
Like in the quadrant. I was confused.
On the line. Okay. So it is on the line because it satisfies the equation. It works in the equation. Okay. What about this line? Y equals negative 1/2 x. How do I go about graphing that?
X, B is 0.
Good. B is 0, right? I'm not adding any numbers, so it's like I'm adding 0. So I start at 0. And then what is my slope?
1 over 2, negative down.
Yeah, good. Negative 1/2, so I go down 1 over 2. Down 1 over 2. Down 1 over 2. 1 over 2. And then back up the other way. Okay, so I have my second line here. Whoops. Okay, close enough. Okay. Can we list a few ordered pairs that are on this line? Give me a point that's on this line.
0, 0.
Good, 0, 0. What else?
6, negative 3.
6, negative 3.
Negative 6, 3.
Negative 6, 3. Give me one more.
Negative 2, 1.
Okay, negative 2, 1. Perfect. So again, every single point on this line satisfies this equation. If I were to plug in x and y into that equation, it would be true. It would work. Okay. Are there any points that are on both lines?
Yeah.
Which point?
2, negative 1.
Good. 2, negative 1 right here. That's on both lines. Okay. And since that point is on both lines, we say that it satisfies the system. Satisfies the system of equations. What I mean by system is just that we have two equations kind of working together. So I have y equals 2x minus 5 and y equals negative 1/2 x. Since this point is on both lines, I know that it would work in both of these equations, both. Not one or the other, but both of them, right? These green points here are only going to work in this equation. And all the pink points, except for that one, would only work in the top equation. It's only 2, negative 1 that works in both equations. Okay. All right, now we have this third line here. 6x minus 3y equals 15. How do I go about graphing that? Is it in y slope-intercept form? No, what form is this in? Huh? Good, standard form. That's what standard form looks like. Standard ax plus by equals c. How do I go about graphing from standard form? Do you remember what I taught you? Yeah, I have to like rearrange the equation. I'm going to show you a different way though of graphing from standard form, and to be honest, I think it's easier than rearranging it. So let's try it. What does it say to do in part A?
Find X and Y intercept.
Find the X and the Y intercepts. That's what we're going to do. So to find the X intercept, that's where my line is going to cross the X axis. So that means that the Y coordinate of that point is going to be 0. So to find the X intercept, we're going to plug in 0 for Y. Let's do that. 6X. That's 6X minus 3Y, but now Y is going to be 0. So 6X minus 3 times 0. What's 3 times 0? 0. So that just kind of goes away. And all I have left is 6X equals 15. How do I go about solving that? Divide by what? Good. Divide both sides by 6. Those 6's cancel out. And then let's use your calculator. What's 15 divided by 6? Good, 2.5. So that is my x-intercept. It's at 2.50. 2.50. And then we're doing just the opposite for our y-intercept. My y-intercept is on the y-axis. That means that the x-coordinate has to be 0. So that means to find my y-intercept, we plug in 0 for x. So I've got 6x, but now x is 0, so 6 times 0 minus 3y equals 15. What's 6 times 0? 0, so that just goes away. And I've got negative 3y equals 15. No. How do I solve for y? Divide by negative 3. So what's 15 divided by negative 3? Negative 5. So then my y-intercept is at 0, negative 5. Okay. So now I have 2 points. I have 2 points. Let's plot those 2 points. 2.5 on my x-axis, that's right here. And negative 5 on my y-axis, that's right here. What happens if I connect those 2 points? What do you notice? It's that exact same pink line, isn't it? Can we figure out what's the slope of this line? How do I figure out the slope between 2 points?
Go up, rise and run.
Good, rise. So how far up do I have to go between those 2 points? 5 over 2.5. And my slope is change in y over change in x, right? So 5 over 2.5. What's 5 divided by 2.5?
2.5.
No.
I mean 2.
Yeah, 2. So if my slope is 2 and my y-intercept is at negative 5, what's my equation of this line in slope-intercept form? Does that look familiar? Yeah, it's the same exact equation as we had in number 1. So even though they looked different, right, y equals 2x minus 5, 6x minus 3y equals 15, they're actually the exact same line. The exact same line. So are there any points on this purple line that are on the pink line?
Yeah.
How many?
Infinite.
Good, infinitely many. Yeah, yes. All of them are the same. right? They are the same line. They're the same line. Okay. For number 4, oh, I meant to have you guys use like colored pencils on this, but you get a colored pencil now. And you're going to draw one more line on your graph that shares no points with y equals 2x minus 5. So you want to draw a line that doesn't share any points with that pink purple line. Draw a line that doesn't share any points at all. Okay, I'm going to come around and check. Right, it doesn't matter where I put my y-intercept. I could make it like super, super close to that line. But if my slope is the same as that slope, I'm never, ever going to touch. Never going to intersect. Okay? Right? Like that. Okay, let's flip over to the other side. We're going to take some notes together, and then I'll give you the rest of the class to get those 3 problems done at the bottom. So, I have, let's see, okay, a solution, xy, to a linear system. Satisfies both equations in that system. And is on the graph of both equations. The solution is the intersection point. A solution xy to a linear system satisfies both equations in that system. That means it works in both of the equations, not just one or the other. Losing my voice. And it's going to be on the graph. It's going to be on the line of both equations, meaning it's at that intersection point. However, a system, a linear system at least, can have one solution if the lines intersect, but it also could have 0 solutions or infinite solutions. Zero, 1, or infinite. That's that symbol is infinite. It's just a sideways 8. Okay, and we're going to draw an example of each of the 3 types of systems. So draw 3 little coordinate planes. Okay, so my first type of system is parallel lines. How many solutions do parallel lines have? None. Lines. 0 solutions. And what do I know about parallel lines and their slope?
Their slope is the same.
Their slope is the same. Same slope, but they will have different y-intercepts. Same slope, but different y-intercepts. Okay. Or I might have intersecting lines. And how many solutions do intersecting lines have? One. They have one solution. And intersecting lines, we can tell if they're intersecting because they're going to have a different slope. If two lines have different slopes, that means they're going to intersect somewhere. Somewhere. Okay, and then my last, how do I get infinite solutions?
Two lines on right over each other.
Yeah, the exact same line. So that's the same line. Infinite solutions. And I can tell that they're the same line because they're going to have obviously the same slope, but also the same y-intercept. Right? Make sense? All right, so you've got 3 problems here. I'll scroll back up to the notes in just a second, but let me talk through the problems real quick. So in number 1, it's asking, is 6, -4 a solution to the system? So your answer should include a yes or a no. But what you can do to figure that out is we just test this point. Plug in 6 for x and -4 for y. If it is a solution, it's going to work in both equations. If it's not a solution, it's going to not work in at least one of the equations. Okay? So test the point in both equations. Right? And then tell me yes or no, is it a solution or not?
But what if x doesn't have a number next to it? What do we do?
You just plug in the 6 for the x, the -4 for the y.
Oh, I see. And would it be negative?
And then in number 2, they drew line Q. This black line is line Q. We want to draw line M so that the solution between Q and M is -2, 8. And then you're going to draw a line Z so that Z and Q have no solutions. And then in number 3, we're deciding, do these have 0, 1, or infinite solutions? So you have 3 answer choices for A and B. Okay, and this information here, same slope, different y-intercept, different slope, same y-intercept, that's going to tell you how many solutions we have. Okay? All right, you've got like almost 20 minutes to work.